This is the last example for hypothesis testing of a proportion. And as I said in the last video, this problem is slightly different. Suppose we're testing the claim that p is less than 0.30. Assume the data result in a test statistic of z equals negative 1.50. What is our decision at the 0.05 significance level or at the 0.10 significance level? So first of all, state the hypotheses. Well, we always know that H naught includes equality, so P equals 0.30. And H1, we're told, is testing the claim that P is less than 0.30. So P is less than 0.30. Select the significance level. Well, we have two. We have to do part A, which would be alpha equals 0.05. And we have to do part B, which says alpha is 0.10. Find the test statistic and the p-value. We know the test statistic. The problem told us. The problem told us that z is negative 1.50. We also know that this is a left-tailed test because our alternative hypothesis is less than. So what does that mean? If we draw our normal curve, zero's in the middle because this is a z-scale, a standard normal. Our test statistic is negative 1.50, and a left-tailed test means we need the probability to the left of negative 1.50. So dig back to the chapter when we did normal probabilities. Our p-value equals the probability that that should be z sub 0, that z sub 0, no, I lied, that z is less than our z sub 0, negative 1.50. So in the calculator, remember, it's normal CDF, and we do the lower boundary, which since it goes all the way to the left is negative bunch of 9s. Our upper boundary is negative 1.50. And because this is a standard normal curve, our mean is 0 and our standard deviation is 1. And when we plug that in, we will get a p-value of approximately 0.0668. If you forget how to get to normal CDF, remember it is second VAERS and it's under the distribution menu, which we're already on. And it is option number 1 under there. Nope, sorry, option number 2, normal CDF. And remember that takes It wants the lower boundary. Then it wants the upper boundary. And then it wants the mean and the standard deviation. So state our decision based on alpha. Well, we had two problems. We had when alpha is 0.05, and we had when alpha was 0.10. So our p-value is greater than alpha when our alpha is 0.05. And so what do? We do not reject the null hypothesis. What about the p-value compared to alpha when alpha is 0.10? When it's 0.10, our p-value is less than our alpha. And so in that case, we do reject the null hypothesis. So that's how you do these if you're given a test statistic and you need to figure out the p-value. First, figure out whether it's right-tailed, left-tailed, or two-tailed, and then use normal CDF to figure out the appropriate probabilities. I will see you guys back for section 10.3, which is hypothesis testing about a mean.